by choosing different values of z, I can have the curves at different levels. All right, for instance, I can set z equals 10 or 100 or 16. And different levels, you will have different intersections. And as you can imagine, if I increase this z value, I will have this intersection to be higher and higher. All right? And these curves are called level curves. So this is called the level curve. A level curve is nothing but the intersection curve between the surface with a level. Okay, you set up your level to be 0, you're getting exactly the xy trace. You set your level to be 1, you're getting the intersection at level 1. You set your level to be 2, you're getting an intersection curve at level 2. So these are the level curves. We will meet this level curve again, but here I'm just letting you know what we mean in the picture. That's the first remark I want to make. Questions? Second remark I want to make is I can switch the rules for x, y, z here, and I'm getting still elliptic parabola, but with different sort of opening. For instance, I can have y is equal to x squared divided by a squared plus z squared divided by b squared. This one still defines elliptic parabola, but the opening, instead of going to the positive direction of z-axis, it is going to the y-axis. So you can easily go over the calculation. So it is opening to positive direction of y-axis. This is a rough picture. You can find the x-intercept, the y-intercept, and so on, the traces, everything will be corresponding to this particular surface. But the shape and everything will be identical with the one. It's just a different by location or rotation. You can rotate around here. I can add more here. So for instance, if I have minus x is equal to y squared divided by a squared plus z squared divided by b squared, what I have elliptic parabola opening to the negative direction of x-axis. So this will be looking like this. So negative direction of the x-axis, this will be what it looks like. Okay, it's not very pretty, but you get the point. So I'm writing the standard forms in one particular order, but you can switch the rules for x on the z. You can even change the sign for this side, not the sign on the right side. Okay, the right side has to be always elliptic. It has to be always the equation of addition of squares. You can switch the order. You can get the same shape with different opening. So we're going to have the same problem for all the following things. So next one will be x squared divided by a squared plus y squared divided by b squared minus z squared divided by c squared is equal to 1. Okay? So since this is a completely new quadratic surface, so let's have it right here. So this is type 3. That's follow. Is 1 shape. I think it's much better to have the picture in the beginning so we can put the conditions in. Alright? So you can have a picture right here. So this will be I probably want this one shape. Basically it means there's one branch, continuous branch, right? Okay? Again, I want to quickly connect the rows of x, y, z right here. I have a constant 1 right in the equation. Okay? I have a constant 1 right in the equation. I have positive terms for x and y, negative term for z. Therefore, this hyperbola is going to the z-axis. to make this hyperbolic to be going to x-axis or y-axis. By changing the rules, I can make these two terms to be positive and this term to be minus, so it's opening to y-axis. I can make x to be minus, y and z are both positive, so it is opening x-axis. Remember, it's going up and down for infinity. Still, let's quickly find all the information of the intercept and put it into the picture. So x intercepts and so. So Kelly, how about you finish this part? X intercepts. Oh, I better write down the equation right here so you don't have that. So they are saying y equals 0. Yeah. So what is the equation? X equals x squared equals a squared, so x is equal to a or negative, right? So minus a and a are two x-intercepts. So this is the a, this is minus a right here. Okay? So how about the y-intercepts? So it's minus b and b. Okay? So we have y-intercepts at b and minus b right here. Okay? And z-intercepts we have x equals y equals 0, so we have minus z squared by c squared is equal to 1. What happens? You have positive minus, this can never happen, so it's no z-intercepts. There are no intercepts, and you can also see from the picture, it is going to z-axis, there's no intercept at all. So right now, we actually have two quick ways to determine which axis is this hyperbolic with one shape. One way is to look at the standard form. If the term for z squared is minus, it has to be going to the z-axis. The other way to look at which axis is its axis is by letting xy equals 0, xz equals 0, or yz equals 0 find intercepts. Am I right? If there's no intercept in one particular axis, that axis has to be the axis of the hyperbolic. Are you with me? You can try to find this from the standard equation or from the intercept. This is exactly the same when we do the two-dimensional plane, right? The two hyperbolics. I want to find which intersection they are, which one it is going. I try to find the intercepts. Right? That way I can easily find what these parabola or hyperbolics are opening towards. So next, I want to find all the traces. So x, y trace. See many. How about the x-axis? Z equals 0. I'm getting plus is equal to 1. Alright? So this one defines ellipsis right at here. Alright? So y z trace. You have x equals 0. So you have y squared divided by z squared minus z squared divided by c squared is equal to 1. We already see this as a parabola. So on the yz trace, on the yz plane, it is exactly the parabola right here. This one, these two branches are defining the intersecting curve. So this is both of them will give you y squared divided by a squared minus z squared divided by c squared equal to 1. Okay? So the last one is actually the xz trace. Xz matrix is pretty symmetric, right? So y equals 0, you get x squared divided by a squared minus z squared divided by c squared is equal to 1. So you have another problem, right? So this one and the other one going to in here. Okay? So these ones are talking about x squared divided by a squared minus z squared divided by c squared is equal to 1. Okay? Questions? So you really have to practice after this. Okay? At least out of the 6 different types, I should be able to tell which one is from the picture. Okay? All the important features of these different quadratic terms in terms of opening, in terms of shape, and more importantly, how they intersect with the x, y, z axis and the planes. Okay? Which means you're going to have to look at these pictures online or on a textbook and start practicing for once. And how these ones are curves, whether the opening is big or small, they are determined by the values of A, B, and C. Alright, you can set up your value for A, B, C. You can make this opening bigger or smaller. With me? So these ones can be modified. So in your homework, online homework questions, they will set up x, y, z, and also A, B, and C. The A, B, and C can be set up to be like 361. They are all perfect squares, so you don't have to be worried about that. So 361 is 19 square, I think. Right. So they are all perfect squares. You can easily find the required the missing intercepts. Okay. So let's go and find the following one. The following one is hyperbolic with 2 shapes. So this one corresponds to 2 minus signs, 2x squared, a squared minus y squared, b squared plus b squared, c squared is equal to 1. This is the standard form of hyperbolic with 2 shapes. Okay? It is standard in terms of the constant in this equation are all normalized to 1. And in this equation, I have 2 minus terms and a plus term. Okay? So the equation, the picture of this one will be looking like this. These are the pictures of hyperbolics with 2 shapes. I'm looking at the pictures on my textbook. I think I'm doing a pretty good job. Okay. That's the one. Still, corresponding to the remark we just made, one sign which is different with the other one will be the one for the axis. Okay, z is the axis. It's opening positive and negative direction of the axis. I can switch the rules of x, y, and z, changing them the sign. I can make this hyperbolic to be y-axis or on z-axis. This is one way to determine its opening. The other way to determine opening is to look at this equation. You can quickly, very quickly, since we already done a lot of the intercepts, I can quickly find there's no x-intercept, correct? Because I cannot let these two to be simultaneously 0. There's no y-intercept either, all right? Which means this hyperbolic will not intersect with x-y plane at all. It will be separated up and down. And the only intercept will be z-intercept. You can let x and y equal 0. There are 2 z values which are on the z-axis. With me? Therefore, z-axis has to be the axis for this hyperbolic with 2 sheets. Right? Because you have 2 sheets, these 2 branches are opening to opposite directions. One is corresponding to z equals c right here. The other is beginning from z equals minus c right here. Okay? So you can easily find x, y, and z 2 points. The next will be XY trace. These ones we want to spend a little bit more time because they are curves. So XY trace is by letting Z equal to 0, all right? If Z is equal to 0, I'm getting minus x squared divided by a squared minus y squared divided by b squared is equal to 1. There can never be such points. Remember, we're all on the real world. Okay, so these are all no imaginary points. So these are all non-negative terms. This can never happen, so there's no xy trace. So yz trace is given by x equals to 0. So we have minus x squared divided by a squared plus z squared divided by c squared is equal to 1. This is a hyperbola intersecting with the z-axis with no x intersection at all, right? So these are two parallels right here, two branches of one hyperbola right here. So this is the one, this is the one. Both of these two are talking about y squared divided by minus y squared divided by b squared. Yz trace actually minus y squared divided by this, divided by b squared. So this is plus z squared divided by c squared is equal to 1. And similarly, the xz trace is going to be y equals 0, so it's minus x squared divided by a squared plus z squared divided by c squared is equal to 1. So these are two branches of one hyperbola right here, and the other one is right here. So these two are given by the equation right here. They will intersect with the axis, but not the x-axis. All right. So these are all the required information for hyperbola with two sheets. So I'm dumping down all the 6 different types of quadratic surfaces at one time. I still believe this is a better way to approach this quadratic because you can do comparison. Okay, we can introduce this